This integration this week, right?
Yeah, some of the variables are actually like they're actually.
Okay, we'll spend some time. Star the ones you need me to work tomorrow. We'll go over.
Yes, and
All right, the barons, yeah. Okay. All right, here we go. Part number 1, the density of bacteria. Da, 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 da. So this one was weird because it gave you R and then it gave you F of R, which was milligrams per square centimeter. So it was already, you're already looking at a rate, right? That's what made this one hard too. So the first one was an easy 2 points, should have been, I hope at least, or at least 1 point for getting the answer. You might not could have explained what it was. Oh. Okay, so whenever we are doing, yeah, I'm gonna do the camera. I think that'll be better. Whenever we're estimating derivatives from a table, we are just doing a rock. Did you get A?
yes. Give me 2 points. I got 0.5 over 6.
What? Yeah, it's.
Are you kidding me?
All right, listen. So it said.
Oh, I don't see any units on that. I don't see units. No, that included the units. No units. Oh, you don't get the point. Oh, no. Get out. Oh, no. Do you even know the unit?
It should be centimeters per milligrams per square centimeter. All right, listen. No, yeah, I said that. But milligrams per square centimeter per centimeter. Third.
No, it'd be 4. No, it'd be 4.
Yeah.
No.
No. Milligrams per square centimeter per centimeter. Okay. 1 point for the 8. 1 point for the explanation. Let me read you their explanation. It said, interpret the meaning of your answer. No. It says, using correct units, comma, interpret the correct. So you can see what I put. When the radius is 2.25 centimeters, the density is increasing at a rate of 8 milligrams per square centimeter per centimeter. So I did have my unit C. Y'all give me my point back. One. Let me read you theirs. And then I've got this detailed scoring guide I'll read. Okay. At a distance of 2.25 centimeters from the center of the petri dish, the density of the bacteria population is increasing at a rate of 8 milligrams per square centimeter per centimeter. Okay, here's a couple of scoring notes. The unit may be attached to the estimate, and if so, do not need to be repeated in the interpretation. If the units attached to the estimate do not agree with the units in the interpretation, then the units in the interpretation are what count. To earn the second point, the interpretation must be consistent with the presented non-zero value for the derivative. All right, let's go to part B because after part A, it just all went to crap. For me, anyway. All right, so, he was what? Really? All right, part B.
That's the right answer.
Is that 244 pi? 269 pi. All right, listen. Part B, here's why part B is ratchet. Look, that is not just f of r. That is r times f of r. That is crap. That is crap. So what you have to do, the 2 pi comes out, you have to do a right Riemann sum multiplying both of these two values together by the height. So it was, the height is 1 times 2. Height is 1 times 2 times 6. The height is, oh, y'all can't even see what I'm pointing at. The height is 0.5 times 2.5 times 10. So you're using the right values, but you're having to do it. And I even put a note so that I would come back and tell you my R there. It's from the right. So listen, normally this would just be f of r, right? And I would just come up here and say from 0 to 1 is 1, 1 times 2. So I don't use that one, but I use this one. This is rectangle 1, this is rectangle 2, rectangle 3, and rectangle 4. I'm using the right ends because it's a right Riemann sum. Okay. Wait, go back. Why do you add the? Because if you look at B, the way it's written, it says R times f of r. So instead of just using f of r, I have to multiply the two of them together. You do not hardly ever see this. All right, so this one, the R is from the table. So you're always so if this is rectangle 1 times 2, you have to get, so a normal right Riemann sum. If this was just a normal right Riemann sum, it'd be 1 times 2 because it's always the y value. What you adding? You're thinking trapezoid. This isn't a trapezoid. This is a rectangle. Height times width. All right. No. All right. So listen, let me give you the point. Listen, guys, I know y'all struggled on this, but it's going to make us better, even though it's really hard. But I need to get through it, and you need to correct it. Right. So if you look at the way I wrote it here, like this is my radius. That's my R. This is my f of r, and this is my height each time. R, f of r, height. Normally, you wouldn't have that R in the beginning. Yes. What, you know what I mean, the distance apart. This is the distance apart. So width then. Okay, points on this one. This was only 2 points. 1 point for the right Riemann sum, 1 point for the answer. All right, y'all. As hard as those two were, understand we're only 4 points in on a 9-point question. Holy cow, I thought that was unbelievable. Part C. Okay, I'm not going to lie, I disagree with their reasoning on part C. Okay, so part C is an overestimate. It has to be with the explanation to get the point. Now,
all right, that it's a rule for Riemann sum, right?
as long as the function is increasing, yes, that's a rule.
Okay, I said because the right Riemann sum against the R.
You literally just said if the function is increasing and it's a right Riemann sum, it's going to be an overestimate. If the function is decreasing,
So I said overestimate because the graph is short. As the graph increases, you go to the right.
you said said the function's increasing. If you said the function's increasing and it's a right ring of thumb, then yes. Okay. All right, now listen. Let me read you their explanation because this is where I do not agree. To me, that's 2 points. I only got 1 point on this. I didn't get both points on this.
As long as I get 8 points.
Yes.
1 point for the.
They said, yes. You get 1 point for the answer with the explanation for stating that because it's increasing. No. What's the other point coming in from, right? Listen to this. They say that you need to take the derivative of r times f of r and use product rule and show that that's always positive, so the function is always increasing. I did not do that because then how are you knowing they were bad? Yeah. Okay, let's go to D. D was worth 3. D was a calculator. D to me was the easiest of all of them. It was strictly calculator. It was very straightforward. Average value of the function, that's 1 over b minus a times the integral from a to b. I used my calculator to find that. You get 1 point for the integral setup, and you get 1 point for that 9.8 value. So that's 2 points right there.
I said it equal. Oh man, I had started that one and never went back to it.
As tough as this stupid problem was, and as hard as it was to garner any points up here, you got 2 points. This one equation right here was worth 2 points. 1 for the integral, 1 for that. Then all you had to do was graph your function, because it says where does the function equal this value. I graphed the function in y1, I graphed this in y2, and I found the intersection for that.
So I get 1 point for that.
We're looking, because you didn't say what it equals.
What equals
Say what it equals.
What equals that?
No, 1 point for that.
1 point for that then? 2 out of 9.
What did you get?
Shut up on that one. See what? Are your bounds on there, your A and B bounds on your integral? So you put the A and B in the integral, but you didn't put the A and the B there? Did you define A and B anywhere? No. Probably not on that one. All right, let's go to 2. Where does it say you have to give range for K?
I feel like I got 2.442.
Oh, that must be a rounding thing. Let me see what they said. You gotta go out 3 places at least. So 2.497 is what they said. All right, number 2. Number 2 got a little bit better. All right, so listen. It asks, this is the equation for anywhere between 0 and pi. But this said at time 1. So at time 1 means from 0 to 1, and you have to add that initial starting point in. Remember we talked about that?
You gotta be kidding me. Wait, hold on. Yes, I got it right.
Let me read you their breakdown. Listen. 1 point for having one correct definite integral. 1 point for one position, 1 point for the other position. So as long as you have one of the 2 definite integrals, you got a point. And then a point for each position.
What if I wrote the integral value? The definite integral.
1 point.
I wrote it for like P of 1.
Am I gonna get a point if I didn't put the integral value there?
Do your work. You gotta show your work.
I didn't know that I had to do an integral. I was being for
You didn't show the integral. Oh, I see what you're saying. Here, yes. Did y'all hear that question? Because that's something that can actually save you time. I don't do it often, but I probably should. She said instead of writing sine of p to the 1.5 or p minus 1.8, she wrote v of p of t and v of q of t, and that's fine because that's already defined earlier in the problem.
What if I wrote p of 1 equals I'm not.
All right, listen. Answer will give you a point. Did you get both of those values right? You got 5.3 and 8.5? 2 points. Yeah.
Can I do P of T, like position, or do I have to do that?
No, you could do that. I don't think the variable matters there. All right, part B. Are the particles moving towards each other or away from each other at time 1? I really had to think through this a minute. I don't know why, but I assumed this was what you were talking about, Slade, whenever you said you just had to think through it, that it was part B. So the velocity at 1 is positive. The velocity at 1 is negative. So P is moving to the right. Q is moving to the left. But it depends on where they started as to if they're moving towards each other or away from each other, right? So if
I said it started at 5 and it's moving right, and it starts at 10 and it's moving left and moving.
Oh.
And at time one, look, we know where they are. So at time 1, here's P and here's Q, so yes, they're moving. So okay.
All right, let me say mine. Towards one another, since P of T starts at x equals 5, and the velocity P of T is positive, it's moving right, while Q of T starts at x equals 10, and D Q of T is negative, it's moving right.
Let me read you the example, and y'all decide if you get the point or not, okay? Listen. 1 point for the direction of motion of just one particle. So if you said this one's moving to the right, or you said that one's moving to the left, you get a point, okay? Your answer with your explanation is only worth 1, but here it is. At time 1, Q is moving to the left. At time 1, P is moving to the right. Therefore, at 1, the position of P is smaller than the position of Q, so it's to the left of the particle. Therefore, at time 1, particles P and Q are moving towards each other.
So even if you said they were moving
If you care to read AP Classroom's scoring notes on your time, I'll be happy to let you see them. Unless it's justified. All right, we got to hustle. Part C, find the acceleration of particle Q at time 1. Is the speed increasing? First of all, how do we tell if speed is increasing or decreasing? Same or different signs. That's right. All right, part C, I did too much work on part C because I did not read carefully and read that we were only talking about particle Q and not both of them. I found the acceleration of both. I used my calculator because this was a calculator problem. And I found the acceleration at 1, so it was 1.0269. Now, because I had already found velocity of Q, and I knew that it was negative, that means I'm negative, that means I'm positive, that means I'm slowing down. I was running out of time here, so I did not give enough of an explanation here. I know I lost a point on that. So your acceleration gives you 1 point. If you have 1.0269, that's a point. If you said that the speed was decreasing because the signs of the two are different at time 1, that gives you another point. That was 2 points.
Oh.
The sign of acceleration and velocity are different at time 1. Y'all did better than me on this one.
I'm already at 5 points.
D?
How do you find
D
the
is 2.
acceleration?
Inderiv. I get inderiv. All right, part D. Part D was a breath of fresh air. Yes, that was 2 points for C. D. D is 2 points. So nice to see a problem like this on a calculator problem, because this is just plug and chug. You got 1 point for showing the absolute value of the integral.
And I remember the
And look at me.
Ooh. No. What the
Put it in the wrong spot.
point. You got
I had the DT.
I have it.
No, because it's 1 point, 1 point. All right. Brother, 3 was a beast. Okay. Okay. My work is all over the place on 3. All right, let me start with part A. There were only 3 parts here. Each one of them, I think, it was 3, 2, and then 4. This was brutal. A was not too terrible. I got through A okay. A was just asking for the area of the region. Here's my graph, and it told you C was 6. So set it to 0 to see where it crosses the x-axis. Yeah, you had to do a U sub on that one. So this one needed to divide by -3, which means I countered that with a -3 outside, did the U sub, you get 16. This was only worth, a little before 3 points. So here's your point breakdown on here. You got 1 point for the integrand. Running it from 0 to 2 with your dx, Logan and Kinsey, you get a point for that. Okay. The antiderivative, for correctly finding the antiderivative, you got a point, and then you got a point for the answer. Because it was running whenever I did my U sub, I changed my bounds from my U equation. Yeah, and then I had switched them up to make it go the other way. No points on that one. Don't beat yourself up too bad about these 3 because they were terrible. The next 3 are.
Why is it more than 0?
Okay, so look, this is where when I use subs, I had to use that equation to change my bounds. So 4 minus 4 squared is 0, and then 4 minus 0 squared is 4. So I switched them up and changed the sign. Oh, 2. All right, part B. It is known. This one was. Part C I was okay with. Part A I was okay with. B I thought was terrible. And B was only 2 points. I wish I'd have skipped it and spent more time on C. It's known, and so that you've got this derivative equation as well as y equals. It says for a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What's the value of C? So I'm looking for a maximum, which is where the derivative equals 0. So you set the derivative equal to 0, and you solve it for x. That's going to give you a maximum, right? I find that x is the square root of 2. Then I took that and I plugged it back in to solve for C, setting my equation equal to 1.2 for that radius. Now, you got 1 point for doing this, for setting the derivative equal to 0. You got a point. I'm not going to lie, I floundered on this one. I lost both points on this one. I did. This is one I did have to look at. So if you got any points on this one, you beat me. Set the derivative equal to 0, and then your answer is a point. And that's it. They thought this one was easy, apparently. I thought this one was... You think it was easy, Wyatt? Did you get it? I did not. He needs to be fired. Darn. I just felt like this one, when they're saying the max... When they're saying the max radius, I just felt like that was not where I would have gone with that problem. All right, part C.
How do you invent calculus?
So the answer is 1.2 over 2.
0.6. 3/5 or 0.6.
Like, I can make gibberish that looks like that too. Does that mean I made a new formula? Like, there's no logic behind it.
All right, I thought part C was the easier. It was just the math that I kind of got lost in, and you will see if you look, if you look at the way my answers formatted in the end, because I didn't have a calculator, I just got fed up with it and was like, whatever, I'm leaving it like that because I wasn't going through finding common denominators and stuff. So I don't know. Wait before you write mine. Let me check mine and make sure it's. Should have been 32 over 3 minus 32 over 5. Do I have that? Yep. Times pi c squared. Yep. And you have, yes. Okay, so it's right. So it says another spinning toy is 2 pi cubic inches. What's the value of C? So what you had to do is set up for cross sections for area. Area is, of course, pi r squared. There's no hole there. So it's just a complete solid. So the volume, here's my equation. I did an equation for the volume. And then I just set that equal to 2 pi. The integrand gives you a point. The limits and the constant give you a point. So I would say all of this all together give you 2 points. The antiderivative, which after you go through and solve all this, you have to find the antiderivative of that integral. That gives you a point, and then the answer is a point. So that one was 4.